Hey guys, Mr. Backberg here. In this video, we're going to take a look at sensitivity. So as we're talking about sensitivity, sensitivity describes how one variable responds to small changes in another variable. So for example, if you're farming, crop yield can depend on yearly rainfall. So if the rainfall has been low, then the farmer could expect to see decreases in the crop yield. Or if researchers are testing a new drug or a new medication, they would be interested in how small changes in the dosage would affect whatever condition it is that they're trying to treat. So in this example, we're going to measure the sensitivity to some medicine. So we've got a patient that enters the hospital with a temperature of 102 degrees Fahrenheit, and they're given a drug to help lower their temperature. As a function of the dosage D, measured in milligrams, the patient's temperature can be modeled by the function T of D equals 99 plus 3 over 1 plus D. And what we want to do is find and interpret the sensitivity of the patient's temperature to the medicine dosage when we're using a dose of 1 milligram. Now, I don't have a lot of room on this page, so I'm going to slide to a new page that I can write some things out. So we've got this function T of D equals 99 plus 3 over 1 plus D, and we're testing this with a dose of 1 milligram. Now what we want to do is think about what would happen if we increased the dosage. So we're going to let this H value represent a small increase in the dosage. So then what we want to do is look at the limit as H is approaching 0 of our function f of x plus h minus f of x all over h. So we're using a dose of 1, so that's going to be our x value that we're plugging in. So we're going to look at f of 1 plus h minus f of 1 all over h. So looking at f of 1 plus h, that means we're going to be plugging in 1 plus h into this fraction. So this is going to say 99 plus 3 over 1 plus h. And we're going to subtract off f of 1, so we're just plugging in 1. So this is going to be minus 99 plus 3 over 2. And this is all still over h. Now I'm going to look at doing some simplifying on top right away. I'm going to distribute this negative in, so then I get a negative 99 and a negative 3 halves. And then what I notice is that this 99 in the front is going to cancel out with that negative 99 on the back. I can also combine these 1s on the bottom of this first fraction. 1 plus 1 would be 2. So we're going to end up with 3 over 2 plus h minus 3 halves all over h. I'm going to rewrite this. Instead of having this being over h, I'm going to rewrite it as 1 over h times 3 over 2 plus h minus 3 over 2. And then I see that we're subtracting fractions, so I want to work on getting a common denominator there. So I'm going to multiply this first fraction on top and bottom by 2, and I'm going to multiply this second fraction on top and bottom by 2 plus h. So then we end up with 1 over h times 6 over 2 times 2 plus h minus, if I distribute this 3, we get 6 plus 3h all over 2 times 2 plus h. Now putting those fractions together, since they have a common denominator, we have 1 over h times 6 minus 6 plus 3h all over 2 times 2 plus h. And then if we combine like terms in that fraction, I'm going to distribute this negative, so that turns that 6 into a negative 6, and then that 3h into a negative 3h. This 6 and this negative 6 cancel each other out. So now we have 1 over h times negative 3h over 2 times 2 plus h. Now with this h on top of the fraction and this h on the bottom of our other fraction, those are going to cancel each other out. So we're left with negative 3 over 2 times 2 plus h. But we're not quite done because we still need to do this limit as h is approaching 0. So if we do the limit as h approaches 0 of negative 3 over 2 times 2 plus h, direct substituting the 0 in there, 2 plus 0 is 2, times 2 is 4, so we end up getting negative 3 over 4. Now what that means in this situation, so that means when the dosage was 1 milligram, then a small additional dose would drop the temperature by 3/4 of a degree. That's going to be it for this video. Thanks for watching.